Study Section 8. The miscellaneous single equation problem. Introduction. Here we will discuss some problems that are often encountered in the course of estimating regression models. We will show how to detect these problems and the remedial measures. Learning outcomes. When you have studied this section, you should be able to point out the multicollinearity problem, explain the consequences of the multicollinearity problem. The multicollinearity. This is a situation where there is the existence of perfect or exact linear relationship among some or all the independent variables in the regression model. In the k-variable regression model that has explanatory variable x1, x2, xk, a perfect relationship is said to occur when the following condition is satisfied. Lambda 1 x1 plus lambda 2 x2 plus lambda k sk is equal to 0, equation 143, where lambda 2 x2 lambda k are constant such that not all of them are 0 simultaneously. In recent time, multicollinearity is used in a wider perspective to include perfect multicollinearity and the case where the x variables are intercorrelated but not perfectly so, such as lambda 1 x1 plus lambda 2 x2 plus lambda 2 xk plus vi is equal to 0, equation 144, where vi is a stochastic error term. The difference between perfect and less than perfect multicollinearity can be shown by assuming that lambda 2 is not equal to 0, which makes equation 143 to become equation 145 as written below. This means that x2 is perfectly linearly related to other variables. This situation will depict a perfect correlation between x2 and variables on the right side. Also, if lambda 2 is not equal to 0, then equation 144 could be written as equation 146 below. This means that x2 are not a perfect linear combination of other x's because it is also determined by the stochastic error term, VR. In addition, it is possible to show multicollinearity among variables in algebraic form, which is put together by Valentine. The circles y, x, and z in figure 10 represent the variation in y, dependent variable, and x and z, the explanatory variables. It is the extent of the overlap shaded area of the circles of x and z that determine the degree of collinearity. In figure 10a, there is no collinearity because there is no overlap between x and z circles. However, in figure B to E, there is a low to high degree of collinearity, which means that the more the overlap between x and z, the larger the shaded area, the higher the degree of collinearity. In an extreme case, if x and z were to overlap completely, that is, x is completely inside z or vice versa, collinearity will be perfect. There are many sources of multicollinearity according to Montgomery and Peake. They are: 1. Multicollinearity can be true method of data collection. 2. True model of population constraints. For example, in the model where elasticity consumption depends on income and household size, there is a physical constraint in the population because families with higher income generally have larger incomes than families with lower income. 3. It can also be true model specification. For example, including a polynomial terms to a regression model, especially when the range of the x variable is small. 4. An overdetermined model can lead to multicollinearity. This is a situation where the explanatory variables in the model supersede the number of observations. Consequences of multicollinearity. The following consequences are encountered in the case of near or high multicollinearity. A. Precise estimation is difficult because of the large variances and covariance of the OLS estimators, despite that they are blues. B. The OLS estimators and their standard errors are sensitive to small changes in the data. C. Due to the difficulties in correctly estimating the parameters, the t-ratio of one or more coefficients tends to be statistically insignificant. D. Also, due to problem of exact estimation, the confidence intervals tend to be much wider, leading to the acceptance of the zero-null hypothesis more readily. And E. Despite the fact that the t-ratio of one or more coefficients is statistically insignificant, R-squared, the overall measure of goodness of fit, can be very high. Detection of multicollinearity. Multicollinearity is a sample phenomenon that arises from a largely non-experimental data collected in most social sciences. There is no unique method of detecting or measuring its strength. It is the rules of thumb that are often used, which could be formal or informal. Some of them are A. High R-squared but few significant t-ratios. B. High pairwise correlations among regressors. And C. Examination of partial correlations. Remedial measures. To overcome the multicollinearity problem, one can try the following rules of thumb. The success of these rules depend on the severity of the collinearity problem. The following measures are recommended. 1. Combining cross-sectional and time series data. 2. Dropping a variable and specification bias. 3. Transformation of variables. 4. Inclusion of additional data. And 5. Reducing collinearity in polynomial regressions. Study section summary. In this study section, you were exposed to the concept of multicollinearity, which describes a situation where there is the existence of perfect or exact linear relationship among some or all the independent variables in the regression model. We also highlighted the consequences, detection, and remedies to the problem of multicollinearity. This is the end of Echo 343. Thanks for listening.